SpaceX is set for thrilling activity as booster and ship stacking unfold at Starbase. Also, progress happens as the massive boosters, numbered 11 and 12, are fully assembled and prepared for testing. There is also news for the Artemis II mission, as a laser communications terminal has been delivered, promising groundbreaking advancements in space communication. But that's not all, as Japan's astroscale robot is gearing up to clean up the dangerous space junk that orbits our planet, ensuring a safer future for space exploration. Also, Webb Telescope's recent discovery revealed the secrets of galaxies that transformed the early universe. Are we truly prepared for the highly anticipated upcoming launch in just 6 and 8 weeks, as Elon Musk hints in his recent tweet? Dive into this video to find out. Let's delve into the exciting progress at Starbase's production site and the assembly of ships. In Mega Bay 1, Booster 11 has been fully stacked, featuring the integration of the oxygen and methane tanks. Positioned next to Booster 9, Booster 11 eagerly awaits its upcoming test campaign, although it's a bit challenging to spot Booster 1. However, Mega Bay 1 is not solely occupied by Booster 9 and Booster 11. Booster 12 has started stacking as well, with significant portions already situated in front of the Mega Bay, forming multiple ring stacks. The substantial presence of components hints at the rapid progression expected for Booster 12. Now, let's shift our attention to the ships taking shape within the Mega Bay. On the right side, Ship 28 proudly stands, boasting a complete assembly, and nearly all its thermal protection tiles are fixed. Though a few gaps still require attention, Ship 28 is on the verge of completion. On the left-hand side, we encounter Ship 29, also fully stacked. The new 2-point attach system at the nose cone facilitated the seamless placement of its nose cone and payload section onto the tank section. The entire stack of Ship 29 rotated on the turntable in the high bay. The utilization of welding robots alongside the high bay ensured the secure fusion of both parts, solidifying the integrity of the ship. In the rocket garden, we find Booster 10 and Ship 26 stationed. It remains unclear whether they await their turn in the testing flow or if they are destined for scrapping. However, signs point towards the former scenario. Venturing further into the production site, notable changes have taken place. The ground fabrication building has undergone partial demolition, paving the way for the significant expansion of the Star Factory building. This transformation necessitated the relocation of nose cones previously housed in Tent 3 to various other locations, allowing for the impending expansion. Ship 30's nose cone, along with those of Ship 32, Ship 33, and Ship 34, were transferred to neighboring areas as SpaceX initiated the demolishing process. The relocation of 4 nose cones beside the tent area vividly highlights the remarkable strides SpaceX has made in ship production. Additionally, the ground fabrication building experienced further dismantling, revealing its skeletal structure beneath the surface. In due course, it will be entirely removed, marking a significant milestone in the ongoing development at Starbase. Among all these advancements, work has been bustling at the orbital launch site. However, the highlight lies in the announcement of new road closures. Initially, testing days were scheduled for June 12th, 13th, and 14th. However, the dates were subsequently revised, leaving only June 14th from 8 a.m. to 8 p.m. as a potential testing day. This crucial day is likely to mark the commencement of Ship 25's testing campaign, an essential step in verifying its readiness for flight atop Booster 9. Also, exciting developments are underway at the orbital launch site in Starbase. With preparations for the upcoming static fire campaign in full swing, notable progress has been made on Ship 25. Recently, the ship was detached from the crane, signifying that the interior work inside the tank is mostly complete. As Ship 25 readies itself for ambient pressure testing below the orbital launch mount, the space industry eagerly awaits the installation of the steel deluge plates, expected to enhance its performance during the second integrated test flight. Meanwhile, the orbital tank farm is a hub of activity as work continues to repair the damaged tanks. The deluge tank area has seen the installation of additional rebar cages, indicating ongoing foundation work. These efforts are likely a part of the preparations for the installation of the Water W system tankage and necessary hardware. The repairs and improvements being made at the orbital tank farm play a crucial role in ensuring a robust and reliable infrastructure for future missions. Back at the orbital launch site, activities takes place. As the second layer of the new Mega Bay is being constructed, cranes can be observed moving around. ready to assist with the infrastructure work at the production site. Excavation work is underway for the installation of the water system pipes, which will be accompanied by the necessary hardware to operationalize the system. Recently, the sighting of pipes being transported down Highway 4 indicates that the installation of these pipes could be imminent, marking progress in the construction of the W system. While the mount itself currently experiences minimal activity, a considerable amount of scaffolding remains at the top. It remains uncertain whether SpaceX has completed most of their work at the mount or if their focus has temporarily shifted to other areas, such as the installation of the W system, before commencing the next test campaign. The orbital launch mount serves as a critical component in facilitating successful launches, and its progress continues to be closely monitored. Towards the end of the week, an exciting sight unfolded at Starbase as massive tanks arrived. These tanks had been spotted in various locations across the country during their journey to Starbase. Local news reports, possibly from Kansas, even captured their passage through towns. The arrival of these tanks is a significant step in the ongoing overhaul and replacement of the orbital tank farm for the second integrated flight test. Initially, the tanks were placed in front of the iconic Starbase sign, capturing attention and speculation. However, they were later relocated to the launch site, where they now stand alongside the water tanks for the W system. This relocation provides an answer to the ongoing developments and signals progress in the preparation for upcoming launches. Now, let's dive into the updates regarding Starbase's readiness for the next launch. Although it may seem like a challenging task, it is not impossible in 6-8 weeks as per Elon Musk tweet as far as we know. The pad modifications are in their final stage, indicating that the necessary adjustments and improvements are nearing completion. Ship 25, which plays a crucial role in the upcoming launch, is on the verge of its static fire test, a significant milestone in the testing process. Before the launch, there are a few essential tasks to be completed. The installation of steel plates and the deluge system is underway, which is expected to enhance the performance and safety of the spacecraft. Additionally, the orbital launch mount will undergo testing to ensure its functionality and readiness. Simultaneously, efforts are being made to get the tank farm ready for action, making sure all systems are in place. The next steps involve the rollout of Booster 9, which will be stacked with the respective vehicles for the mission. Extensive testing will be conducted to ensure all components are functioning as expected. Once the testing phase receives approval from the Federal Aviation Administration, the launch becomes imminent and the countdown begins. With these exciting updates, the progress at Starbase is evident. The arrival of massive tanks signifies the ongoing efforts to improve infrastructure and support future missions. The installation of the ship QD and the various preparations at the launch site and the tank farm demonstrate the meticulous planning and execution that goes into each launch. Up next, NASA Laser Communications Terminal, delivered for Artemis II moon mission. NASA's upcoming Artemis II moon mission is set to test the capabilities of Orion's systems for crewed spaceflight, paving the way for future lunar missions. A key component of this mission is Orion's Laser Communications Terminal, known as the Orion Artemis II Optical Communications System, or O2O. This cutting-edge technology is designed to provide increased data rates and open up new possibilities for scientific discoveries. Unlike traditional radio wave systems commonly used by NASA, laser communications systems like O2O offer significantly higher data transmission capacity. This means that O2O can send and receive more information in a single transmission. Steve Horowitz, the O2O project manager, explains that O2O is capable of transmitting 4K high-definition video from the moon at an impressive speed of 260 megabits per second. In addition to video and pictures, O2O will facilitate the transmission and reception of procedures, flight plans, and act as a crucial link between Orion and mission control on Earth. Once the data is collected, O2O will transmit it via laser signals to one of two ground stations, specifically chosen for their minimal cloud coverage: Las Cruces, New Mexico, or Table Mountain, California. The quality of images and videos sent from Orion through O2O will be influenced by the cloud coverage at these ground stations. Therefore, the selection of these locations ensures that the transmission can be as clear and reliable as possible. The development of the O20 laser terminal is part of the Space Communications and Navigation Program's optical infusion effort, which aims to demonstrate the effectiveness of laser communications in various missions. O20 is the result of a successful collaboration between engineers from NASA's Goddard Space Flight Center and the Massachusetts Institute of Technology Lincoln Laboratory. This partnership has previously led to significant laser communications missions, including the Lunar Laser Communications Demonstration in 2013, the Laser Communications Relay Demonstration in 2021, and the Terabyte Infrared Delivery Payload in 2022. By showcasing the advantages of laser communications in different space environments, SCAN highlights the immense potential this technology holds for future missions. Before its delivery to Kennedy Space Center, the O20 laser terminal underwent rigorous environmental testing to ensure its resilience in the harsh conditions of space. These tests ensure that the payload can operate effectively and reliably, even in the challenging space environment. Laser communications terminals like O20 play a crucial role in enabling the transmission of vast amounts of data from space to Earth, supporting advanced scientific investigations. The data collected by Artemis II will not only contribute to NASA's future lunar missions, but also help establish a long-term presence on the Moon and, ultimately, expeditions to Mars. The arrival of the O20 laser terminal marks a significant milestone in NASA's efforts to expand our understanding of the cosmos and further humanity's exploration of the solar system. Up next, Japan's Astroscale has a new robot tug to clean up space junk. Here's how it works. Astroscale, a Japan-based company, has presented an innovative solution to address the mounting concern of space junk and orbital debris in low Earth orbit. With the increase of satellite constellations from companies like SpaceX's Starlink, OneWeb, and Amazon Kuiper, the issue of space debris has become increasingly pressing. While some satellites are designed to deorbit themselves, not all do, leading to a congested and potentially hazardous space environment. Astroscale aims to tackle this challenge with its end-of-life services by Astroscale Multiple Vehicle, specifically designed to capture and deorbit decommissioned satellites. In a recent video released by the company, the need for action is highlighted, citing over 2,200 defunct satellites and more than 630 instances of debris-generating collisions in orbit. The video showcases the deorbiting process of the ELSA-M spacecraft. It begins with a visual inspection of a rendered client satellite, followed by alignment and docking maneuvers. Using its thrusters, ELSA-M then gradually lowers the client satellite's orbit, directing it toward a trajectory that will ensure safe disintegration during re-entry into the Earth's atmosphere. Once the client satellite is set on a destructive course, ELSA-M detaches and corrects its own orbit to prepare for the next target. To support the deorbiting process, Astroscale has revealed its Generation 2 docking plate, which boasts a remarkable on-orbit lifespan of over 15 years. This docking plate facilitates the grasping of satellites in need of deorbiting, providing a crucial starting point for various servicing options and promoting responsible use of Earth's orbital resources. Astroscale's ambitious plans are supported by funding from the UK Space Agency and the European Space Agency. The company aims to demonstrate the commercial viability of its multi-satellite deorbiting service, positioning itself as a pioneer in this field. In partnership with mega-constellation manufacturer OneWeb, Astroscale's UK subsidiary has signed a deal worth $3.2 million to provide reliable disposal services for OneWeb's aging satellites as they retire from operation. The upcoming 2024 demonstration of the ELSA-M vehicle will involve the disposal of an inoperable OneWeb satellite equipped with a customized docking plate designed for capture by the ELSA-M grapple fixture. This demonstration is a crucial step toward proving the efficacy and practicality of Astroscale's solution. With their ELSA-M vehicle and innovative approach to space debris mitigation, Astroscale aims to address the growing concerns surrounding space junk and orbital debris. By removing inoperative satellites and actively promoting responsible space practices, Astroscale is contributing to the preservation of Earth's orbital environment and the long-term sustainability of space activities. Up next, NASA's Webb proves galaxies transformed the early universe. New data from NASA's James Webb Space Telescope has revealed remarkable insights into the era of reionization, a pivotal period when the gas between stars and galaxies transitioned from being non-transparent to completely transparent. This groundbreaking discovery has shed light on the reason behind this transformation, revolutionizing our understanding of the early universe. During the era of reionization, which occurred approximately 1 billion years after the Big Bang, the universe underwent significant changes. Initially, the gas in the universe was intensely hot and dense, but over hundreds of millions of years, it gradually cooled. Then, a profound shift occurred as the gas became hot and ionized once again. The key factor driving this transformation was the formation of early stars within galaxies. These stars emitted sufficient light to heat and ionize the surrounding gas, ultimately making it transparent over millions of years. For a long time, scientists have been seeking concrete evidence to explain these remarkable transformations. The latest results from the James Webb Space Telescope have finally unraveled the mysteries of this reionization period. The telescope has not only confirmed the existence of transparent regions around galaxies, but has also precisely measured their size. The transparent regions are massive in comparison to the galaxies themselves, similar of a hot air balloon containing a suspended pea. This data provides evidence that these relatively small galaxies played a pivotal role in driving the reionization process and clearing vast regions of space around them. Over the course of the next 100 million years, these transparent bubbles continued to expand and merge, eventually leading to the entire universe becoming transparent. The team of researchers, led by Simon Lilly of ETH Zurich, deliberately focused on a time just before the end of the era of reionization, capturing a snapshot of the universe with a patchwork of gas in different states, which is neither completely clear nor entirely opaque. To acquire these groundbreaking results, the research team utilized the James Webb Space Telescope in conjunction with observations of a central quasar, the luminous, active, supermassive black hole acting as an enormous flashlight. By studying the quasar's light as it traveled through various patches of gas, some opaque and others transparent, the researchers were able to gain extensive information about the composition and state of the gas. Webb's observations also enabled the identification of galaxies near the line of sight, revealing that these galaxies were generally surrounded by transparent regions with a radius of approximately 2 million light-years. This remarkable finding showcased the galaxies actively clearing the space around them at the conclusion of the era of reionization. To put this into perspective, the area cleared by these galaxies is roughly equivalent to the distance between our Milky Way galaxy and its nearest neighbor, Andromeda. Describing the appearance of these galaxies, Jorrit Matthey, also of ETH Zurich, explained that they were more disorganized compared to galaxies in the nearby universe. Webb's exquisite images displayed galaxies in the process of actively forming stars, with evidence of multiple success events. These early galaxies had an adventurous youth, bustling with energetic activity. Additionally, Webb's data confirmed the presence of the most massive black hole currently known in the early universe at the center of the quasar observed in this field. Weighing 10 billion times the mass of the Sun, the existence of such colossal black holes in the early universe poses another intriguing puzzle that scientists strive to solve. The research team, Emission Line Galaxies and Intergalactic Gas in the Epoch of Reionization, plans to continue their investigations by exploring galaxies in 5 additional fields, each anchored by a central quasar. Webb's extraordinary results from the first field have far exceeded expectations, revealing 117 galaxies from the era of reionization, surpassing initial expectations. This remarkable outcome has solidified the unique power of the James Webb Space Telescope in unraveling the secrets of the early universe. The research team leveraged the capabilities of Webb's near-infrared camera to combine conventional images with data obtained from the instrument's wide-field slitless spectroscopy mode. This mode allows for the capture of a spectrum for every object within the images, transforming Webb into a spectacular spectroscopic redshift machine, as the team describes it. These groundbreaking findings have far-reaching implications for our understanding of the universe's evolution. The confirmation that galaxies played a crucial role in clearing the surrounding gas and making the universe transparent provides a crucial piece of the puzzle in the quest to comprehend the origins and development of the cosmos. Furthermore, Webb's insights into the era of reionization have revealed fascinating details about the nature of early galaxies. Their appearance and active star formation processes indicate a dynamic and energetic environment, with numerous supernovae events shaping their evolution. These discoveries not only deepen our understanding of the early universe, but also fuel the curiosity and excitement of scientists as they uncover more secrets about our cosmic origins. That was all the space news for today. Can we really expect to witness the launch of a Starship in just 6-8 weeks? Share your views in the comments section below. And if you want to see more interesting videos, don't forget to subscribe with all notifications enabled so you don't miss out on the latest news on space.